If electrons had a home address, the first thing you would like to check their street number, and that's the principal quantum number, right? And it tells us how far the electron lives from the nucleus and how much energy it has. Hi everyone, welcome to Chemistry Portal. I am Sudhanshu Kumar, and today we will decode this fundamental number of quantum mechanics. Let's start. So first thing, to define the position of an electron in an atom, we have to define some terms that we will use to find the position of electron. Okay, see, very simple. To locate the position, to define the position of an electron in an atom, we have to define some term. Okay, so first term, that is called atomic orbital. Atomic orbital. Right. And atomic orbital is nothing but it is a three-dimensional region around the nucleus where an electron is most likely to be found. Okay, already we have discussed this atomic orbital in the previous video. Okay, you can check in the playlist, right? So we can write here again, atomic orbital, it is it is the three-dimensional region around the nucleus, where an electron is most likely to be found. Right? Okay. And this region I am talking about, this 3D region, and this thing came from mathematical function, okay, that is called wave function, which is a solution of a Schrodinger equation. Okay, we will not go in so much depth. Okay, that's the part of quantum mechanics in so much detail. Okay, and because this course is of introduction to organic chemistry, that's why we will not go in so depth of quantum mechanics. Okay, I will just try to give overview of quantum numbers here, okay, in this lecture session. Right, but still I will write it here, okay. So this region, this three-dimensional region, right, this region came from comes from mathematical equation, and that is called wave function. Okay, wave function. That is wave function. Okay, and that wave function, which is a solution, this wave function, it is a solution of the Schrodinger equation. Solution of Schrodinger equation. Schrodinger equation. Right. So this is a very simple definition. I tried to explain you in a very simple language. Atomic orbital, it is the three-dimensional region around the nucleus where an electron is most likely to be found. Okay, understood? But if you see the this thing by the quantum mechanics, so this region, this three-dimensional region, it comes from mathematical equation, and that is called wave function, and this wave function, it is the solution of Schrodinger equation. So we can write one more definition of atomic orbital, So straightforward, okay, and that is the actual definition of the atomic orbital in the quantum mechanics, okay. Write it here, or you can write or the wave function of an electron in an atom is called atomic orbital. This definition is so straightforward, okay. The wave functions of an electron in an atom is called atomic orbital, right? And this is the actual definition, okay, from the quantum mechanics, okay. And this is like I explained you in a very simple language, okay. Both are same thing, but this is more like a very simplified version of definition of the atomic orbital. Okay, fine. Now imagine you have to describe an electron address inside an atom, right? Okay. For that we have to use 4 quantum number to give it a complete description. Okay. Suppose you have to describe electron address inside an atom, and to do that we have to use 4 quantum number to give it a complete description. Okay, understood? And that 4 quantum number is first of all quantum number and that 4 quantum number, first of all, that is a principal quantum number, principal quantum number, okay, and that is denoted by a small n. Second one quantum number is azimuthal quantum number, AZI, okay, azimuthal quantum number, and that is denoted by a small l. Third quantum number is magnetic quantum number, and this is denoted by a small m, or you can denote by m and a small l in the subscript. Okay, like this. Both are same thing. Now fourth quantum number, that is a spin quantum number, and that is denoted by a s, or you can write m, and in the subscript write here a small s. Okay, that is s here, s. Okay, in the subscript of m write here s. So this is the symbol of a spin quantum number. And now we have magnetic quantum number, a small m, or you can write a small m and a small l in the subscript. Okay, so these are the symbols of quantum number, and this quantum number we will use to describe, to locate the electron address inside an atom. Okay, it's like your home address. Okay, and we know that to locate the home address we need all the address, right? Suppose your home is in the Kolkata, so to locate your home I need all the details, right? A street number, road number, pin code, and all the things. So similarly here also, to locate, to describe an electron's address inside an atom, we need 4 quantum number, okay, to give a complete description of electron. And one thing I want to tell you, this 3 quantum number n, l and m, this 3 came from, these are the basically solutions of the Schrodinger equation, okay. This n, a small n, and l and m, these 3 quantum number 1, 2, 3, these are the solutions of the Schrodinger equation, okay. So you can write it here. These are the solutions of the Schrodinger equation. Schrodinger equation. Okay, clear? Right. But this spin quantum number not came from Schrodinger, okay? Note it down here. This spin quantum number not came from Schrodinger equation. Very important. Schrodinger equation. Only 3 quantum number, that is n, l and m, these 3 quantum number came from as a solutions of the Schrodinger equation, okay, and the spin quantum number not came from Schrodinger equation. Okay, fine. now suppose, note down one more thing, okay, that is very important. Okay, I will give some very practical example to understand the orbital and the electron and whole thing. Okay, see, suppose, imagine an orbital as a house, okay, that provides a specific address where an electron to be found. Okay, understood? Suppose an orbital as a house, okay, that provides a specific address where an electron to be found. Okay, so let's draw one house here. Very beautiful house. This is your house. Okay, here we have window, door. Here we have window. Right. Now so this whole is what? This is your house, okay? This is your house. Clear? Now, and suppose this house is an orbital, okay? This house is acting as an orbital. Suppose, imagine, okay? Whole house is working as orbital. And inside this house, a person is there, inside this room, okay? Inside this house, a person is there. Suppose this is your person. One guy is standing here. Okay, this guy is standing, living in this house, right? Now imagine this person as a electron. This person as an electron. Okay, try to imagine, okay? You have a house, and this house is acting as an orbital, that is atomic orbital, okay? Orbital means atomic orbital, simple, okay? Let me write a full name here, okay? Atomic orbital. Otherwise you will get confused. Atomic orbital. Okay. Whole house is atomic orbital. Inside the house, there is a person, and this person, suppose this is electron. Simple. Okay? This person is acting as a electron. Right. Now, to describe the house, whole house, suppose to describe the house, to locate the house, we need first three quantum number. Okay? Understood? That is N, L and M. That is principal quantum number, azimuthal quantum number and magnetic quantum number. These three quantum number are used to locate the house or to describe the house. Right or not? It means these three quantum number are used to locate the orbital, atomic orbital. Okay? House means what? Atomic orbital. Okay, but now when it comes to identify or describe or locate the electron, means this person, if you have to locate this person, this electron, then we need one more quantum number, and that is called a spin quantum number. Understood? Okay, to locate this electron in this house, we need one extra quantum number, and that is called a spin quantum number. So, in a very simple term, if I say here, if I write here, very important, note, to describe the orbitals, the atomic orbitals, we need three quantum number, and that is the N, L and M. Okay? And similarly, to describe the electron, an electron, we need four quantum number, one extra, and that is called a spin quantum number, N, L, M and S. Okay? Clear everyone? Right. Now, in this lecture, we will talk in more detail only about principal quantum number. Principal quantum number in this session. Okay? So now let's start our first quantum number, that is called principal quantum number. Principal quantum number. And that is denoted by a small n here. Okay? So basically, actually, we had already discussed in the previous video, right, that atomic orbitals are grouped into different cells at a different distance from nucleus, right, and each cell is indicated by the principal quantum number, right. So write it here. First point, each cell is indicated by principal quantum number, by principal quantum number, okay, a small n, right, and this quantum number proposed by Bohr, Niels Bohr, okay, so you can write here, proposed by Niels Bohr, and after, when the Schrödinger came, and by the Schrödinger equation, this is verified, okay, this principal quantum number, right, okay, so originally it is proposed by the Niels Bohr, okay. Now, third point is principal quantum number n, it is a positive integer, okay, it is a positive integer. It is a positive integer. and start from n equal to 1, 2, 3, 4, 5, infinity, theoretically. Okay, understood? Infinity. But all the numbers should be a positive integer. This is very important. Okay, so much important, this line, this positive word, positive integer. Right, now now and the value of n, this value of n, the value of this small n, it will indicate the size of the orbital, size of the orbital. Okay, so write it here. It value of n, value of n indicates the size of orbital, size of the atomic orbital. We will discuss in more detail how it can affect the size of atomic orbital in the second quantum number, that is called azimuthal quantum number. Okay, clear? Now, third point, fourth point, right? Sorry, this is the fifth point. Fifth point, as the quantum number increases, if you increase the principal quantum number, then electron energy also increases. Right? So you can write here, as n will increase, as the principal quantum number increase, electron energy increases, and can hold more electrons. Okay, and this all thing I will show you. Okay, in just a moment. Okay, understood? I will try to give you feel also, like how the cells looks like. Okay, understood? And how it can affect the size of the atomic orbital, and how electron energy will increase and hold more electron if you try to increase the n. Okay, we will discuss all the things. Okay, now write one more point here. Number of atomic orbitals. How to find number of atomic orbital in the nth cell? In nth cell, that is equal to n square. Very important. Okay, I will talk about this. Okay, don't worry now. I will draw a cell diagram. Now the last point, that is maximum number of electron in the nth cell, that is equal to 2n square. Okay, this shoe formula very important. Okay, so first point is each cell is indicated by the principal quantum number, that is called n, and this is proposed by the Niels Bohr, and it is a positive integer, n equal to 1, 2, 3, 4, 5 and so on up to infinity, and the value of n indicates the size of the atomic orbital, size of atomic orbital. And if you try to increase the n, as the principal quantum number n will increase, electrons energy will also increase and can hold more and more electron in the higher n value. Okay, and number of atomic orbital in the nth cell, that is a n square, and maximum number of electron we can fill present in the nth cell, that is a 2n square. Okay, that is a 2n square. Now see, now I will draw a cell. Okay, I will I will draw a cell here, fresh cell. Okay, right, one more, okay, I think this should be here, yes. Now try to, okay, we will make one more cell. See, this is the 2D diagram of a cell around the nucleus, okay. I will show you 3D also, don't worry. So here we have in the center of the atom, we have here nucleus, right? And these cells, see here, each cell is indicated by principal quantum number n. So it means every concentric cell inside the atom, around the atom, we have cell, right? Okay? Sorry, very sorry. Around the nucleus, you have concentric cell, right? And that cell, each cell is denoted by principal quantum number that is called n. Okay, understood? So we can write here, this is your n equal to 1. The first cell is what? N equal to 1. And the second cell is n equal to 2. And the third cell is n equal to 4. Okay. And the fourth cell is called n equal to 4. Right. So here, n equal to 1, n equal to 2, n equal to 3, and n equal to 4. Right. Okay. Now, and this n equal to 1, 2, 3, 4, 5, and this is also labeled as K cell. N equal to 1, it is called K cell, and n equal to 2, it is called L cell, 3 equal to M, 4 equal to N, and 5 equal to O, like that, on and so on. Okay. So first cell, we can write this as a K also. Okay, K also, K, and this is called L, this is called M, and this is called capital N. Okay, understood? Like alphabets. Okay, K, L, M, N. Again we have O, and so on. Okay, so these are the quantum number, principal quantum number, and that principal quantum number tells the cell number. Okay, cell number. Understood? Concentric cell here. So first cell having a n equal to 1, and those, okay, and this is your this n equal to 1, this cell very close to nucleus, right? Very close to nucleus. Okay, this cell is very close to nucleus, right? And if you go more far away in the second cell, third cell, fourth cell, then what happens? Then the size of the cell will also increase, right? Size of the cell will also get increased. Okay. And now suppose if you have electron here, or if you have here, so this electron present in the first cell, and that's why this electron having a lower energy in the comparison to this electron. So as you go above, far away from the nucleus, in the next cell, next to next cell, then the energy of electron increases. Okay, understood? Very important. As the value of n increases, electron energy will also increases and can hold more electron. Clear? Very important. Okay, so this electron having a more energy than this electron. Understood? Clear? Right? Okay, fine. So if you go far away from nucleus in the different cell, higher number of cell, then the electron energy will get increase. Right? Okay, fine. Now I want to give you a feel of cell, concentric cell that is around the nucleus in the 3D. I will just copy one picture from here. Okay, copy. Here, paste it. Yeah. See very carefully. This red one. Okay. So in the center of the atom, you have nucleus, right? So in the center of the atom, you have nucleus here. Okay. This is your nucleus here. Okay. And whole thing is your atom, right? And around the nucleus, you have concentric cells. See here, red cell. Then we have a green cell. Then we have a blue cell. Try to imagine in the 3D. Okay, try to visualize how the cell look like. Okay, understood? Okay. So this is your atom here. Whole thing is what? Atom. And inside the atom, you have here nucleus in the center, and around the nucleus you have cell, right? You have a region that is called cell. This concentric cell, red one, this is the first cell. Green one, this is the second cell. Blue one, third cell. Purple one, fourth cell, right? Okay, so I can write it here. This is your first cell, red one. First cell means n equal to 1, and if we talk about the second cell, that is the green one. Second cell, that is n equal to 2, and a blue one. Third cell, and this is n equal to 3, and here the purple one, purple color, I have to choose it. Okay, purple color. So this is your purple one, and this cell is what? Fourth cell, and n equal to 4. Okay, I hope you are trying to visualize this in a 3D. Okay, understood? And okay, so till now we have discussed the principal quantum number. So we have already I told you that atomic orbitals are grouped into different cell. Okay, so in each particular cell, inside the cell, we have again what? Subcell. Inside the subcell, you have atomic orbital. These all things we have discussed in the previous video. Okay, you can check the link in the link of that playlist in the description box. Understood? So all the atomic orbitals are grouped into a different cell. Understood? At a different distance from the nucleus. Okay, and each cell we denote by principal quantum number. Understood? Right? Clear, everyone? Okay. And in the next lecture, we will talk about a azimuthal quantum number. Okay? Right? And before that, this two formula is very important. Number of atomic orbital in the nth cell. Okay, we will take some more questions also when all the quantum number will get over. Okay, then we do some questions also. Okay, don't worry. Right? Okay. So if you find this helpful, hit the like button, subscribe to Chemistry Portal, and leave a comment with your questions. See you in the next lecture, Thank you everyone. Thanks again.